Hello and good evening. Welcome to Adafruit Show and Tell. I'm Liz and I will be hosting tonight. If you would like to join the stream to show off your projects, you can find a link in the live broadcast channel in our Discord server, which is available at adafruit.it/discord. First, we're going to kick things off with my friends at Adafruit, and then we will hear from folks from the community. So first, let's hear from Jeff.
Hello.
Hello, how's it going?
It's going well. I picked up some Z80 computers last month. This is a Xerox 810 motherboard.
Very cool.
And up here are two chips. The capacity of each of those chips is 2 kilobytes of flash storage. And that's like the only storage built into this thing. And it's enough to like boot the operating system. But this was designed to work with a dedicated CRT monitor, of which I only have one, and I've got 3 of these boards. So I'm like, I want to change it so that I can use it just with the serial ports, of which it has 2 on the back and then a keyboard connector.
Very cool.
So I made a CircuitPython EEPROM programmer with a Raspberry Pi Pico, and it can program those 2K chips that this board requires. And it's actually a pretty simple process. The original version of EEPROMs had to be erased by a UV light, and then you had to hook them up with not only 5 volts, but like a 12 volt or a 16 volt supply.
Okay.
And then with the 2816s, the electrically erasable ones, all you need is 5 volts. And so this is powered off of 5 volts. And then because it's a parallel EEPROM, there's like 12 address lines and 8 data lines and 4 control lines. And the CircuitPython program just, puts out a byte and puts out a byte and an address and says write, and does that 2048 times. And you pop the chip out. Whoops, that will go back together. You pop the chip out and put it in the board and see if it works. And you repeat that until your program does something. And that's what I'm doing right now.
Very cool.
But anyway, I will put a link to the gist with the code for that in the Discord if anybody's interested in programming EEPROMs with CircuitPython.
Excellent. Thanks so much, Jeff. I'm sure a lot of people will find that to be really handy.
All right. Well, that's what I'm up to.
Nice. All right. Have a good night.
You as well.
Okay. Next, we are going to go to John.
Hey.
Hey.
So great. I'm so excited about what Jeff was just showing because I have this game on NES. It was written for NES, and I bought it. It was written recently. I bought it just as a ROM, and I really want to play it on an actual NES. And I've been looking into like EEPROM programmers for Nintendo cartridges, and maybe Jeff's thing will be the secret.
Yeah, because they can usually be these really specialized things. So I think
right.
Really
There's
cool.
these $200 gizmos, and I'm not like going into the cloning business, so I just want to do it once. So this could be fortuitous. So.
Yes.
I'm excited about that. Speaking of gaming stuff, the thing I've been working on a little bit has been progressing, and it is this. Let me switch cameras here. It is this wild and wacky controller, which is a PlayStation 1 controller. And from kind of here down, it looks an awful lot like PlayStation, except flattened out into kind of neat form factor. And then from here up is the very familiar wheel from the Game of Life, if you're familiar with the Game of Life board game. So this was made in Japan only. There was a Game of Life game, and there were a few sequels to it. And Takara, the manufacturer, who also does a lot of like physical toys and board games, they decided to make a specialized controller for it, which is wild. It is a rotary encoder, optical encoder. So this just spins, and then there's a little light transmitter receiver package there. And I've been working on figuring out the best way to basically find the right library and the right language to be able to use this as a really rapid clicker. So I've got a wacky little PlayStation CircuitPython controller library sort of working. It has some issues, but the most important thing is I've got it working with USB HID now to send mouse clicks every time it registers the dial spinning. So if you look in my little window here, you can even hear a sound effect. I'm playing some clicker game. There's a billion of these things out there. This one's on itch.io. It's I don't even know what its name is. No title. Simple game for Game Jam. Smash the red button. And you're supposed to actually press it at a particular moment, but I don't care about that. What I really just care about right now is super rapid clicking. So when I spin the wheel, I get bazillions of clicks. I get something like 16 per second or something like that. I'm not going to win this game because I don't really know how it works. It'll go either direction because this is just the same. It doesn't have like two encoders or different shaped markings, so it doesn't know which way you're going. So you couldn't use it for Pong or anything like that, but it is a lot of fun for super rapid, ridiculous clicking, and that's the progress on that. So if that's useful to anyone, I will probably put this up in a quick guide. It is running on a Pico, Raspberry Pi Pico here with CircuitPython. It is also a general purpose library for these controls, so any of these controls will do things. Cool. I just have them sending HID letters right now. I suspect this could also be useful, however, for the turbo button that some third-party controllers have, because being able to grab those super fast messages of clicks is beyond what a person could press with their finger.
Right.
Is sort of what we're dealing with here. So that's the weird and wild thing I'm up to.
Excellent. You always have the funky interfaces.
This was Phil Perrone. Phil Perrone's like, hey, look at this weird thing I found online. Get one. See if you can use it. So
I love it.
I love weird controllers.
That's great. Well, thanks so much, JP.
Great thing.
Okay, have a good one. Okay, next we'll hear from Scott. Hey, Scott, how's it going?
Hello. I'm pretty good. I'm in the middle of debugging. Can you tell from my face?
A little.
But I'm not debugging what I wanted to show. Okay. So Jeff and I had this back and forth. I had this idea that I wanted like a mounting plate for Stemma QT and Feather boards. Yeah. And I did this grid pattern where it's just 0.1 inch holes that are like 0.2 inches apart. That's great, except that some of them are, some of the holes on the boards are an odd number of 0.1 distances away.
Yeah.
And that's why you can see here that the feather's only on two sides. And then Jeff came up with this really cool kind of swirl pattern that basically connects some holes together that gives you some flexibility to like adjust them. So
very cool.
What I have here on my screen share is a 3D view of KiCad. So this is KiCad's rendering of this board. And Lamore is going to order a prototype. But Jeff came up with this little bit of a swirl pattern that gives you more flexibility on how you place everything on there.
That's great.
And I was very excited about it. It looks really cool. And I wrote a generator today to do this board generation. So you can tell it like it's 5 high and 10 wide. And this board ends up being the same size as the one I showed, which is 3 inches by 6 inches.
Okay.
But this version, the future version will be a lot more flexible in terms of positioning. Now, it's not going to obviously give you a full 0.1 inch grid, but it will give you, Jeff did the numbers, and you can at least put some feathers on it.
That's great.
And you can get a little creative if you need to too. So wrote the generator here. The pattern repeats every 0.6 inches. So that's kind of what these... the silk screen is showing, and I've actually added coordinates is here as well. So if we ever have like learn guides that people are talking about, like where does it go? Like here we've got coordinates for it, and the backside's also got the same coordinates on it as well.
That's really cool. The first thing I thought of when you and Jeff were showing this stuff is I'm constantly having to design like mounting plates for the project guides I do. So if we had something like this, like I could save so much time just being like, I can just attach it with these screws here and not have to worry about the layout and everything. So that's awesome.
Totally. And especially for me, where I'm like very not mechanical, having like a generic mounting board, it will be really helpful as well. The reason I was thinking about it is I had this vision of making a like Euro rack like modular thing based on SynthIO. So you would have a control surface that was built on top of a board like this that then would control SynthIO under the hood. So you'd have the same interactions you would have with a regular Euro rack, but it wouldn't be doing audio. It would just be detecting how things are plugged in and what the settings are and stuff like that. Cool. And this is kind of like the base plate for building bespoke interfaces, and that's something that CircuitPython's really good for. So I'm excited to see what people make with it.
Excellent. Well, thanks so much, Scott, and I look forward to hopefully using this grid in the future.
I know, me too. Yeah. Thanks, Liz.
All right, have a good one. All right, next we are going to hear from Eva. Hey, Eva.
Hey.
How are you?
Good. How are you?
Good, good.
Let's see. I'm gonna try to set my screen share up.
Okay.
Yeah. So I have been working on this. Been working on this project for the last few weeks. It is a LoRa messenger that integrates with Signal.
Excellent.
And it has the option to be encrypted. Obviously, I would never encrypt that because that'd be breaking the law. And
yes.
Yeah. So you can do a few things with it. So first I'll explain like what's kind of going on here. We have these two UIs on the left, and this on the right is my Signal window. This one is the this is just one of the RFM RP2040s that it's just connected to my computer.
Okay.
This is one that is connected to my computer, and I have both of these, and this one is also connected with Signal.
Okay.
So what I can do is I can just write here. I can write that I'm sending that from Signal, and it'll take a few seconds.
I see it. Yeah.
Yep. So then it gets this here, and it sends it here, and these are both two separate microcontrollers. And then if I want to go here, I can send it again, and I can send this to Signal. And after a few seconds, sometimes it likes me to resend it. Yep. And it should be sending just now.
There we go. Yeah.
Yeah, so that's about it.
That's super cool. That's going to be so handy for folks.
Yeah, thanks.
Yeah. And this is going to be a guide coming up soon?
Yeah, I'm hopefully going to try to get the guide done by the end of this week.
Excellent. All right, looking forward to seeing it.
Thanks.
Cool. All right, well, thanks so much for coming by, and have a good night.
You too. Bye.
Bye. All right, and that looks like it's going to do it for Show and Tell tonight. Thanks, everyone, for coming by with your projects. In about 18 minutes, right here is going to be Ask Engineer with PT and Lamore, so stay tuned for that. And until next time, keep working on your projects. Bye.